Alright, hi guys. Today what we're going to be talking about is using scientific measurements. So this is going to be any measurement that we take during a lab or that we're reading about in any text, and there's going to be some specific rules that go with everything. Alright, so the first one that we want to talk about is what we call accuracy and precision. So these two things just talk about how good our measurements are. Now, accuracy, the definition is the closeness of measurements to the correct value or the actual value, and then precision is just how close a set of measurements is to each other. So usually the graphic that we see with these things is that of a dartboard. So if we get something that kind of looks like that, let's do this, right? So we have an outside ring here, okay, an inside ring, and then a bullseye. Okay, so if this was our bullseye and we're going to be making some marks on there, something that was accurate would be the ones that are close to the middle. So let's say if we had, right, 3 dots, and all those are pretty close to the middle there. So those would be an example of something that's accurate. Now, they're also precise, and the reason that they're precise is that they're close to each other. Now, if we get rid of those, okay, so I hope we got rid of some of our bullseye. We'll put that back. Okay, so if we go again, and this time we see that they are kind of all over the place, right? Those definitely would not be precise because they're not close to each other. In addition to that, if you notice kind of the area that they all encompass, see there? It doesn't exactly kind of hit the exact middle, right? So the middle of those is kind of where that blue dot is, right there, and that's not exactly bullseye. Instead, if we're going to clear all that again, let's make that a little bit bigger, get this faster. Okay, so if we make another new bullseye, we can see what's going on. So we're here, alright. Okay, so if there's our bullseye, if we were looking at it, and this time, if we want something that is accurate but not precise, notice how they're kind of all surrounding that bullseye. They all go around it, but they're not actually, none of them are bullseyes. Yet if we look at the average of them, okay, the average of them is going to be somewhere right in that middle circle, the blue. And so we really do have something that's both precise and accurate. Alright, let's go ahead and move all that to the side because we can talk about the next thing. Okay, but those are going to be two of the definitions that we want to use. Now, how we tell whether something is accurate and precise is by something that we're going to use called experimental error, and that's just in a certain measurement. There is going to be an exact correct value, but we're going to need to figure out how close we are to that correct value. So when we're looking at it, we're going to have two equations to use for that. The thing that we really want is the experiment, or the percent error. That's the real key number for us, but the error is also going to be another good one. So the error is just the accepted value, and this would be the correct value. And this value is something that you're going to be given. Okay, the correct value, or the accepted value, is always a given. So that's something I would give you, say this is what it actually should be, and the experimental value, this one, okay, that's what you're going to find out. And if you just take the accepted value minus your value, that's going to give you the error. From there, it's to find the percent that you're off. You just take the error that you just found and divide it by the accepted value, because remember, these are the same thing, okay? And then multiply it times 100 to get a percent. So those are some other useful things that we're going to be using as we go. Alright, so things to keep in the back of your head, just in terms of definition-wise, that we're going to use. So we got accuracy, precision, we got error, we got percent error, and what we want to spend the rest of it talking about is how do we get those things. And this is going to be what we call significant digits, and this is what we're going to spend the rest of this video talking about. So significant digits, and what they're actually often called is they're going to be abbreviated and not significant digits, but simply sig figs. All right, so sig figs, what these are is, this is when we're taking a measurement, how accurate we can actually be. So I don't have a ruler drawn, so let's draw one real fast. Let's say that these are the big marks, and we got 1, 2, 3, 4, 5, 6, 7, 8, 9. Big mark, 1, 2, 3, 4, 5, 6, 7, 8, 9. Big mark, 1, 2, 3, 4, 5, 6, 7, 8, 9. Big mark. Okay, let's say that this is a meter stick, right? So this would be 1 centimeter, 2 centimeters, 3 centimeters, so on and so forth. If we are wanting to measure a line, so let's say that my line starts here. Okay, and it's going to go to right there. I can figure out how long this is by reading everything that I have down below. Okay, so let's see if I'm reading this correctly. So what we're going to see is that this is, oops, okay, we have right here is 1 centimeter, and here is point something, right? So we're going to have 0.1, 0.2, 0.3, 0.4, 0.5, and now we know that it's 1.5, and do we know where it's at in between these two things? Well, not quite. So here's what we're going to do. We're going to blow it way up. Alright, so now it's going to be a little bit easier to see, and we can go ahead and guess that it is about right in between 0.5, which is here, and 0.6, which is there. So our actual measurement isn't just going to be 1.5. What it's going to be is 1.55. And the reason that we get that extra 0.5 is because somewhere in here we can make one guess. So we can guess up to 1 digit. So what that looks like is 1.5, 1 because we know it right here, 0.5 because we can see that right here, and then our last digit, the one that goes right here, is when we are guessing. Okay, so we're going to guess that last one is 0.55. Alright? So this is how we're going to measure and record, our measurements so that we have the correct number of significant figures in every measurement. Alright, so let's go ahead and get a definition down for that. I'm going to get rid of this. There's quite a few of them to get rid of. All separate. Alright, there we go. So here is going to be our definition for our significant figures. Alright, and what that is a significant figure is in a measurement all the digits that we know plus 1 digit that we are guessing. Alright, so that's going to be our definition for significant figures, and that's just, again, how we can use those so that we are recording stuff appropriately. Okay? Alright, so there's some of our definitions. Now, there are some rules if we just read a measurement for how many significant figures are in that measurement, and this is what we're going to spend a lot of time doing in class, is going through and calculating how many significant figures, because a lot of the units that we're using are going to be multiplying two measurements together, or subtracting, or dividing, or adding, and so we just kind of need to know how to use these measurements appropriately. So this is, well, make sure we add it correctly. Alright. Here is the chart that we want to use. I know this might be a little bit hard to read. What it's showing is that any zeros that go, so I'm going off of this first one right now, and that's any zeros that appear between non-zero digits, those mean a big deal. So in the first two examples, notice how we have 40.7. All three of those mean something. Okay, that zero is important. And then the same thing here, 87,009 kilometers. Again, those mean that we have exactly 87,009. Those zeros are important. The second rule here is that zeros that are before every other digit, those aren't very significant. Okay, that just tells us an order of magnitude, and kind of what we're doing there is that, you know, it's not necessarily telling us what's going on with that. Okay, it's just moving that number left or right. Okay, here, numbers at the end, so number 3, numbers that are at the end of the number or at the end of a decimal point. Okay, so it has to be both, at the end of the number and to the right of the decimal point. That just means how exact it is, and so that is important. Okay, so the first example, 85.00, that means that we're not rounding to 85. That means that it is exactly 85.00. And then the same thing with the other one. So you do count those numbers. And then number 4, that's showing you that the zero is at the end of the number, but to the left of they may or may not be. Basically, this has to do with, are we estimating or not? Because remember, a significant figure is all of the digits that we know plus one guess. So in these numbers over here, are we guessing that it's 0.7? Yes or no? And if we are, that means that we're pretty exact. All right. So, but if we have 10 zeros after that, then that means that we know that it's that exact of a number. So it just has to do with how precise and how accurate all of these measurements are. All right, guys. That's kind of the start to using scientific measurements and significant figures, and we will do a lot more with that in class.